Welcome to today's Explainer, where we're diving into the terrifying and honestly wildly fascinating science of what would happen if the dinosaur-killing asteroid struck Earth right now, completely without warning. We've got a lot of ground to cover, so no long intros today. Let's just jump right into the data and the destruction. To kick things off, let's ask the ultimate doomsday question. What exactly would happen to us if that massive space rock paid us a surprise visit today? Now, we all know it wiped out the giant reptiles millions of years ago, right? But how would our modern, densely populated world handle that exact same impact? The source material we're exploring today breaks this down step by horrifying step, and let me tell you, it is a wild ride. All right, Section 1, the initial strike. Let's look at ground zero. So the asteroid would hit with the mind-blowing energy of 1 million nuclear bombs. I mean, just try to wrap your head around that scale for a second. With zero warning, the impact wouldn't just crush things. It would instantly vaporize absolutely everything within a 100 to 200 kilometer radius. If you're anywhere near that impact zone, there's no running. It's just instantaneous vaporization. And the sheer scale of the immediate human cost here is absolutely staggering. Because our modern world is so interconnected and heavily populated, an estimated 100 million people would die instantly in that vaporized blast zone. That immense tragedy unfolds in just the first few milliseconds of the asteroid making contact with Earth's surface. But the immediate danger doesn't stop at the edge of that crater. Get this, the sheer volume of the impact sound would be so intensely deafening that it would instantly drop anyone standing even 300 kilometers away. The acoustic energy alone is literally deadly. So just from the blinding flash, the vaporization, and the literal noise of the rock hitting the Earth, a massive chunk of the population is completely wiped out before the dust even begins to settle. Moving on to Section 2, earthquakes and global tsunamis. Let's look at the secondary effects. Because the impact would immediately trigger the most violent, dangerous earthquake humanity has ever witnessed. We aren't talking about buildings swaying or minor cracks in the pavement here. We're looking at an unprecedented seismic event that violently fractures the Earth's crust, destroying infrastructure way beyond the initial blast zone. It's an earthquake on a scale that completely defies all of our current historical records. So the really crucial point is what happens when that unprecedented earthquake shakes the world's oceans. It would spawn monstrous tsunamis so massive they'd easily swallow coastlines around the entire globe. Entire countries bordering oceans would be inundated, and an estimated 3 billion people would drown. Just like that. This takes the casualty count from the tens of millions straight into the billions, all within hours of the initial strike. Which brings us to Section 3, the deadly deep freeze. This is where the long-term nightmare begins. A really grim progression immediately follows the strike. First, the impact throws up an unbelievable amount of black smoke, dust, and poisonous gases, trapping them right in our atmosphere. This essentially blocks out the sun. Second, without the sun's warmth, an extreme freeze sets in globally. Third, that sudden change in weather and the total lack of sunlight means crops fail worldwide, triggering mass starvation. And finally, the water supply becomes completely contaminated, turning drinking water absolutely lethal. Basically, even if you survived the physical destruction, simply taking a sip of water could kill you. And this hellish, freezing environment wouldn't just last a season or two, it would drag on for thousands of years. We're talking about a dark, freezing world where survivors on the surface are systematically wiped out purely from unrelenting hunger and unquenchable thirst. The atmosphere is toxic, the ground is completely barren, and the water is literal poison. This leads us to Section 4, the few survivors. Who actually makes it out alive? Well, those left on the surface face inevitable death, battling poisoned elements, mass starvation, and freezing temperatures. On the flip side, the absolute fraction of humanity that actually survives are the underground dwellers. These are the negligible few who manage to reach deep, well-supplied underground bunkers at the exact right time. They're the only ones insulated enough from the toxic atmosphere and the freezing temperatures to carry on the human race. But before we accept a total doom, let's look at Section 5, the real modern threat. What are our defenses? The reality today is actually very different from the time of the dinosaurs. Our modern technology has advanced incredibly far.
If we spot a massive asteroid approaching Earth today, we actually have the technological capability to change its direction. Through advanced orbital mechanics and deflection technology, we could make it so the asteroid cleanly dodges the Earth, just narrowly missing us. We aren't sitting ducks like the dinosaurs were. We actually have the science to fight back.
So the chilling final takeaway from today's analysis isn't actually the danger from space. As the source material points out, the threat to Earth isn't from outside, it's from its own people. Because we have the technology to stop an asteroid, the stark realization is that humanity's greatest existential threat is actually ourselves. Our actions and our divisions pose a far greater risk to our survival today than a rogue rock hurtling through the cosmos. So I'll leave you with this final thought. If we can unite technology to conquer the very forces of the universe that wiped out the dinosaurs, what's stopping us from saving ourselves from each other? Thanks for joining this explainer, and keep questioning everything.